Welcome back everyone. Today is day 37 of solving Geeks for Geeks problem of the day, and today's question is clone a linked list with next and random pointer. So the question says here you are given special linked list where each node has a next pointer pointing to its next node. You are also given some random pointers where you will be given some pairs denoting two nodes A and B. A's random would be pointing to B. So construct a copy of the given list. The copy should consist of the same number of new nodes where each node has its value set to the value of its corresponding original node. So both the next and random pointer of the new node should point to the new nodes in the copied list such that original and copied list pointers represents the same list state. None of the pointers in the new list should point to nodes in the original list. So for example, if there are two nodes x and y in the original list where x random should point y, then for the corresponding two nodes new x and new y in the copied list. So in the copied list, the new x random should point the new y. So return the head of the copied linked list. So given here, if there is any node whose arbitrary pointer is not given, then it's by default null. Don't make any changes to the original linked list. So this question is mentioned as hard, and it's the most important question based on linked list topic, and it's asked in many companies. So let's understand the question first, and then we'll move on to the brute force, and then slowly we'll optimize the solution. So given here, question is like we have given a linked list with next and random pointers, and we need to create a copy of this linked list by using these two pointers. So let's understand the structure of this linked list. Here I have drawn the structure where a linked list will contain a data value, a next pointer, and a random pointer. Here the random pointer can point to any node or it can point to itself. So the structure here would be a node with a int value of data and the two node star values. So here next pointer would point to the next node and random pointer would point to any of the following nodes. So since we need to create a copy of this original list, what we can initially think would be to create a new linked list with next pointers. And when we try to think of the random pointers, what we can do is to iterate over this linked list. We'll find for each node that it points to the next node here. So we'll iterate over this node and we'll find a random node pointer to which it is pointing, and we'll again run a loop over this linked list to attach that random pointer. So here we'll do two for loops where the initial loop would be to find the node in the original linked list, and another for loop to iterate over the clone linked list to attach that random node. So here time complexity of creating new linked list would be O of n, and attaching random nodes would give us O of n square, where we use two while loops to find the random node in the original linked list and to attach that random node in our clone linked list. This would be the initial thought. That would be our brute force solution. And here the time complexity would be O of n square and space complexity would be O of n. As the question required us to do it in O of n and space complexity would be O of 1. So we need to find a way to reduce this O of n square to attach these random nodes. So the initial step would be to create a new linked list, which would be easy to create. That would be done in O of n time complexity. So here we just need to find a way to optimize this time complexity for attaching these random nodes in our copied linked list. So here approach 2 would be to map these values from original to the random. So we'll use an external data structure where we'll map these original nodes to our new created copied linked list, and then we'll, with the help of this map, we can easily calculate and find a way to connect these random nodes from the original to the new linked list. So here the steps would be same. We'll create a new clone linked list which would take as O of n time complexity, and finally we should find a way to access these random pointers in the original linked list, and we'll find that formula to connect these random pointers in our new linked list. So if we observe properly, since we need to access the random pointer for this node, for example 1, what we can do is, since each and every node is mapped to our new linked list nodes, we know that random pointers are there for original node, but we don't have any random pointers for our new copied linked list. We can connect these random pointers with the help of these original random pointers which are being mapped. Since in our original linked list 1 is connected to 3 originals random, we also need to connect the same random pointer in our new linked list. So in this way 1 should be connected to 3 as well in our new copied linked list. So what to do here is to, like, first we need to find the random pointer for the current node in our original linked list, which would be accessed through original node of random. And then finally we need to connect this 3 to 3, which can be done using our map data structure where 3 would be connected to 3. So the formula we can derive from this analysis would be to, since we need the new nodes random, so here the formula would be clone nodes random would be equal to the originals random, which would be 3 here, original random which would be 3, and since we need to connect 1 to 3, so here clone nodes random would be the mapping of originals random through our map data structure. So in this way we'll connect 1 to 3 with the help of the originals random and with the help of our external data structure map. So the final equation would be clone nodes random equals to the map of originals random. So finally, with the help of our map data structure, we can find a way to optimize the attachment of random pointers from original node to copy linked list. So in this way, we can do this operation in O of n time complexity, and here the time complexity would be O of n to create a new linked list, and here we have used a space of O of n as we are mapping each and every node to the new linked list. So here we have optimized from O of n squared to O of n. So let's move on to the code and let's try to submit whether it gets accepted or not. Then later on, based on our verdict, we can move on to the further optimal approach. So let's code this approach where we use external map data structure. So our step 1 would be to create a new linked list. This is the clone linked list, where we'll take clone head, which would be initially null, and clone tail, which would be null. Now with the help of the original linked list, we'll create this clone list. So we'll take a temp variable which would be pointing to the head initially. So while temp is not equals to null, we'll take the help of insert at tail function where we'll send the head node, a tail node, and the data, which would be temp data, and we'll move this temp variable to the next point. So let's create this insert at tail function, which would be void. We'll pass on the head, we'll pass on the tail, and we'll pass on the data. We'll create a new node with the help of new function, and we'll store the data value inside it. So if our head is null, we'll point both head and tail to it, and we'll return from there. Else, tails next would be pointing to the new node, and we'll point tail to our new node. So in this way, our first step completes, where we created clone list, and now our step 2 would be to create a map. So I'll take the help of unordered map, which maps from node star to node star. I'll name this as old to new. Now I'll take the original head and take the clone head. Here clone head would be pointing to the clone head and original head pointer would point to the original's head. So we'll run a loop until or unless these two pointers becomes null. We'll map these values. Let's name this as original node and clone node just to understand it better. So we'll map this node to our clone node and we'll move these two pointers one step further. So in this way we have created our step 2. Here step 2 is to map to linked list, and finally our step 3 would be attach random pointers. So we'll again point this original node to our head and clone node clone head. So now we'll run over this original node until or unless it becomes null. And since we derived this equation, if we need to find the clone nodes random, it would be with the help of this mapping, which is original nodes random. In this way, our original nodes random would be copied to our new nodes linked list. So with this equation, we'll attach the random pointers in our new copied linked list. So after this particular step, we'll move these two pointers one step ahead to attach and check whether that particular node has a random pointer or not, and if it has, we'll connect with the help of this equation. So finally, we have created our clone list. We have attached this next pointer. So one pointer is done by creating a clone list, and we have mapped these two linked list node value. We have used a map just to make sure that random pointers are being attached properly. So our step 2 would be to use the help of map and attach the remaining pointer, which is random pointer. So in this way, we have created a copied linked list where we have attached this next pointers by creating a new linked list, and we have also handled this random pointers with the help of our map data structures. So finally, we'll return clones head, which would be our new linked list. So let's compile and run this. It's working, so let's submit. As you can see, this problem got accepted successfully. Here the time complexity would be O of n to create this clone linked list, and since we have used external data structure, base complexity would be O of n. So but our expected time complexity here is O of n, which we have accomplished, and our approach takes O of n space complexity where we have used external data structure map. So we need to find a way to optimize our space complexity and convert this from O of n to O of 1. So let's optimize this approach and let's not use this external data structure map here. So let's further optimize this approach and make sure that we don't use this map data structure. So if we observe properly, and so what we need to do here is, instead of storing these links which we have mapped from original to the clone link list, instead of storing, we directly change the links. So let's understand with the help of example here. Since they are asking us to optimize the space complexity, they are directly saying us to change the links instead of mapping the links. So here I've done the both original and clone link list. Initially what we were doing was that we were storing these links in a map data structure to calculate and copy these random pointers. So instead of storing it in map data structure, we directly change the links. Here we change the links in the form of the next pointers which were pointing to its next node. Instead of pointing to its next node, we'll point this directly to the clone linked list node. So these links were initially mapped in our and stored in our map data structure, but right now we'll directly link to its node instead of storing it. And coming to the next pointers are being removed here as we are pointing the original's node next to the clone's node. And here the clone's nodes next would be pointing to the next node of the original. After changing the links and modifying the links, linked list would be looking as this. So from 1 to 1, and then from 1 to 2, then from 2 to 2, and from 2 to 3. So from 3 to 3, and from 3 to 4, and it will map with 4 to 4, and it will point from 4 to 5, and in this way the links would be changed. So our linked list would be looking like this. So 1 to 1, 1 to 2, 2 to 2, 3 to 3. So in this way our modified linked list would appear. So we can observe that we are just adding this cloned linked list in between our original node. So why we are modifying in this way? Because we can create a new linked list with the help of next pointer, but just to keep track of the random pointers, we just need to place these copied linked list values inside our original linked list. So in this way we can keep track of the random pointers. So after doing this particular step, we can easily find out the random pointers from the original node, and we can easily attach these links to our clone copy linked list. And it can be done through this step. So for example, we'll keep a temp pointer to our head. The temp next would be our clone value as it is present in between our original linked list. So here one is a temp. So clone nodes 1 would be our temp next. So just to attach this clone nodes random, we need to find the temps random. So here temp random would be 3. Temps random gives us the access of the value which is 3 here. So we need to attach this same value to our clones node which is temps next random. So we need to find the temps next random value. The initial step here would be to create a clones linked list, and we'll add all these clone linked list in between our original node linked list. And just to copy our random pointers, we have done this particular second step. And to attach the random pointers to our clones linked list, the equation would be here that to temp next, which is our clone node, random would be temps randoms next. Here, this is our temp next clones value. We need to find this temp next random value which is present on our LHS side, which should be equal to our temps randoms, which is 3. Its next would be our clones random. Final right hand side value would be temps randoms next. So in this way, we'll attach these random pointers with the help of adding these clones linked list in between our original linked list to keep track of these random pointers and to derive this particular equation. And finally, after attaching these random pointers, we'll again detach these links so that it gets removed from this original linked list and we can easily return the clones linked list head. So this would be our third approach, and since we didn't use any external data structure, here the space complexity would be O of 1 and time complexity would be O of n. So this is as per our expected time complexity and space complexity. So in this way we have accomplished both our expected time complexity and space complexity. So it was a pretty great solution and it's asked in many interviews. So you can observe it in our tags where it's been asked in many companies. So let's move on to the code and let's try to submit this. So this is a code for the optimal approach where the time complexity would be O of n and space complexity would be O of 1. Here the step 1 would be the same, just to create a new linked list, which would be our clone linked list with the help of function insert at tail. And our second step would be to add this clone node in our original list. So this can be possible with the help of these three steps, which would be running in both original node and clone node. So let's try to understand these three steps and we'll move on to our next steps. So here I have explained through this diagram. Since we need to change these links just to ensure that we should not use any external data structure. Here what we can do is initially to keep track of the next way of linked list structure, we'll use a pointer next, which would be our original nodes next, just to keep the track of remaining linked list. And we'll then change this particular nodes next value to our clone nodes to attach these two nodes. Instead of mapping and using external data structure, we'll here trying to change the links. So before changing links, just to keep track of the remaining linked list, we'll use a node pointer next. We'll change the links using original nodes next, which is equal to the clones node. And finally, we'll move this original node to our next node. The same method goes with the clone node, where instead of this node pointing to our next node, we'll remove this link and will point to this original node's next node, which would be possible using this next node, which would keep track of the remaining clone nodes structure, and then we'll change this link using clones next equal to our original node, which is pointing here. So in this way, we'll accomplish our step 2, that is adding clones node in between our original node. So our third step would be to copy these random pointers, which can be done using our equation, which is temps next random is equal to the temps random next. And our fourth step would be to detach these links and converting it back into our two different linked list, which can be done through these steps by again taking these original nodes and pointing to our head, and we'll run a loop over this particular modified linked list, and we'll try these steps in both original node and clones node. And it can be done using these two steps, that is original nodes next pointing to our nodes next. Here, since we need to remove this link and again point to this original nodes next, here the steps would be original nodes next should be the clones nodes next. In this way, this link would be removed and again this link would be attached. And we'll move this original node to our next node, and again original node, which is pointing initially to this clones node next, we'll remove this link and we'll attach to this original node's next value. So in this way, we'll detach these links and again create two separate links for both original node and clones node. So in this way, we'll create two different linked list and we'll return our clone linked list head. So these are the two steps where original nodes next would be pointing to the clones node next, and we'll move the pointer to the next value. And same goes with clones next, which is pointing to our original nodes next. We'll be moving clones node next to the next value to process it further. And finally, after this step 4, we'll get two different linked lists. One would be original linked list and another would be copied linked list, and we'll return the copied linked list head. So in this way, using these 4 steps, we have tackled this particular problem without using any external data structure, and the time complexity here would be O of n. So let's try to compile and run this. It's working. So let's submit. As you can see, this problem got solved successfully. We have completed this problem in our expected time complexity and space complexity. So this is it guys for this video. I hope you like this explanation, and we have discovered three different approaches, from brute force approach to our optimal approach. So please give it a thumbs up, share with your friends, and subscribe to my channel for such great coding content. I'll see you in the next video. Thank you.